Hello and welcome to our algebra lesson for today. Today 5-1. So we're starting our new chapter 5 here. Today we're going to be talking about the rate of change and slope. So rate of change and slope. So let's go ahead and start off as we always do with our anticipatory set. All right, in our anticipatory set today, I'm going to go ahead and talk about something that some of you may have been doing. I know those of you who have done the track meet before, you've done this. There's a few different events when you go to track and field. It's a great sport. Some of you may be doing this in high school. I hope you do, because it is a great sport. It's a lot of fun. Two of my favorite events in track and field were the long jump. Now, I wasn't all that great at the high jump, but the long jump I was pretty good at. No, I wasn't good at all. So there's a difference. There's a very big difference in these two events. The long jump and the high jump, they both have to do with jumping, but they both have very different purposes. So I'm going to kind of sketch out for you what it looks like to do the long jump and the high jump. So the long jump has this sort of sand pit right here and a very long runway. And what you do is there's this little strip of white on the runway, and as you run towards it, you jump as far as you can. Now, when you take off, normally you can't step over this line, so you sort of throw your body sort of like knees first. Your arms are kind of behind you, and you fly out here, and then when you land, you're sort of propelling your body forward. So you have sort of the bent knees, and you swing your arms forward to get as far as you can. And I guess you'll fall out of the pit at that point, but there we go. And you try and land. You try and go as far as you can in this direction. Now, with the high jump, it is complete. Very soft. Across. And you need to run sort of in a circle. And when you get to this point, you jump, but you sort of jump at a weird angle. You're sort of throwing yourself up and backwards, and your arms swing up like that. And you try and go up and over this post right here. And you fall down, and as you come down, you try and get your feet out of the way, air, and sort of curve your body over. So that's sort of how you do these two events, and they have very different purposes. I was very good at the long jump because when I can actually jump this distance, but I can't get off the ground very high. So this will tie into what we're going to talk about today, because of the two different things. You can look at just this image right now and decide which one do you travel faster up than you do out. Well, obviously it's the high jump. You go up first and you go as high as you can. You're not worried about distance. But on this one, the distance goes, but you don't go as high, right? And that's the sort of the point of either of these two. So if you can do this, if you can get this high jump, this is more your event. If you can go forward, this is more your event. And you can sort of see what we're talking about in this rate of change and the slope. So the rate of change, our rate of change this way, is not vertical at all. It's very horizontal. Here it's very vertical and not very horizontal at all. For today, and we'll start out with our standard. Okay, I'm back. My cat tried to rip up the couch. Fun times, fun times. Okay, so let's go ahead and get our is going to be F.IF.6. And this standard states that we must calculate and interpret average rate of change of a function presented symbolically or as a table. And then finally, we're going to estimate the rate of change from a graph. All right, so this first standard talks about how we're going to be calculating and interpreting the average rate of change, which is what our title is. And we need to be able to do this not only through numbers, but we also need to go through this when we look at a graph. Okay, so that's the first thing we're gonna be working with today. The second standard is F.LE.1b. And this standard, a little shorter, states that we need to recognize situations in which at a constant rate per unit interval relative to another. And that last one might be a little confusing, but constant rate per unit, all that's saying right there is that we're going to be trying to calculate the unit rates. Really, we're just going to be simplifying our rates down so that they are unit rates, which, if we remember back, I believe it was chapter 2, a unit rate is when we have some quantity over one of another. Things like that. Okay, let's go ahead and get into our input. And we have a few pieces of the language of the discipline to take care of. Language of the discipline. Draw out our ellipse right there so we know what we're talking about. And the first term, our first term that we're going to be talking about is the rate of change. The rate of change. And you've probably heard this before. I know last year you've done a little bit with this as well, with the rate of change. And the rate of change states it shows the relationship between two changing quantities. When one quantity depends So what it's saying there is that when there's an independent and a dependent variable, when one quantity depends on the other, the following is true. And when you have that, what you see is this. The rate of change equals dependent variable over the change in the independent variable. So that's sort of our equation that we can use when we have independent and dependent variables. That's the rate of change. Now the second term is going to be slope, when we are finding the slope. And the slope is the ratio of vertical change of a line on a graph. The ratio of vertical change that is vertical change over horizontal change, which is easier to say by saying rise over run. Let's take a look at what that would look like. So I'm going to go ahead and draw a little graph down here. We have our x and we have our y axes. Sorry, I'll put that so you can see it. There we go. And on this, we'll have distance in feet. And down here, we'll have time in seconds. And to label these, let's go ahead and say this is going to be 10, 20, 30, 40, 50. And over here, we'll just go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have a little graph down here. Now, on the graph, if this is our line, let's say that one of our is right there, one of ours is right here, one of ours is right here, one of ours is right here. Okay, so that is our line. We connect those. If we have that, we can look at any of these points. Now you see some of these points, and we anyone that I want. Let's say I'll pick this one, and I do the rise. There's the rise. I rose what? I rose 10. The run now is the horizontal 1, 2, and that's going to be 2. So my rise over run is going to be 10 over 2. And that obviously can be simplified down to 5. Right? 5 over 1, we wouldn't need it. And that's how we get our unit rate. So 10 is going to be 10 feet over 2 seconds, would actually be 5 feet per second. So whatever we're graphing here is moving at 5 feet per second. Okay, and before we move on to some examples, there's one thing I want us to write down. So go ahead and put the rules icon. We're going to put down a nice thing to remember, which we call the slope formula. And anytime you want to calculate the slope of a line, remember this formula, which is slope y2 minus y1 over x2 minus x1. And if you look, all you need to calculate slope is 2 points. So that's our slope formula. Go ahead and write that down. Then I'm going to go ahead and switch to a new piece of paper so I have more room. And we're going to get started We have one little note to write down before we get some modeling done of several examples. So I'm going to go ahead and draw my flower. And on this flower, what I want to make sure I'm writing is that you can use ratios to show a relationship between changing quantities. Such as vertical and horizontal change. So that's basically what we just talked about. We're using ratios to solve relationships, to show relationships between quantities. Now, the quantities we're talking about a lot when we're talking about those graphs are those vertical and horizontal changes. All right, so let's now move in and get into some of our modeling. Let's see some of these. First is finding a table. Now, this one is my least favorite of all these because it's a lot of writing, a lot of looking at numbers, but it's not too bad. So let's go ahead and write a sample problem we could have. And this problem could be that the upper band is marching. Sometimes I have those morning practices. The upper band is marching. Is their rate constant? What does this represent? So we're looking for two things, whether or not the rate they have is constant, and once we find that, what does that represent? What does that rate represent? So the table we have is about the distance marched. On one side, we're going to have the time in minutes. So here's my table. One minute, they have traveled 260 feet. In 2 minutes, they have 180 feet. In 4 minutes, they have traveled 1,040 feet. Okay, so that's what we have as our table. We need to find whether or not the rate is constant, whether or not they're moving the same amount each time, and once we find that, what does it mean? So let's take a look at our formula that we're going to want to use, which is the rate of change equals the change in the dependent over the change in the dependent over the change in the independent. Now we have to decide which one is the independent and which one is the dependent. Is it related? Well, let's find out. What relates, or what is caused because of the time? Well, the dependent variable, the distance, is going to depend on the time. If you walk for less, you're going to have less distance. So this is going to be our dependent variable, and this is our independent variable. So over here, I'm going to just put a D, and I'll put an I. This is our dependent, this is our independent. So now, let's go ahead and solve these. So our rate of change is going to be seen by the change in the distance over the change in the times. And now you're going to start to see some real similarities. This is the similarities to our unit rates. So think back to when we were doing unit rates. The first thing we do is we're going to choose two of the rows. Well, it's easiest to just choose the first two. We're going to say the rate, so for rows 1 and 2, the dependent and the change in the independent. Well, the change in the dependent is going to be 520 minus 260 over 2 minus 1. So the dependent first, the independent second. Very nice. So now we just simply going to be 260 over 2 minus 1 is 1. Okay, so there we have 1 unit rate. Between rows 1 and 2, the rate of change is right here, and it's a unit rate, 260 steps per 1 minute. But we cannot say that that's it yet because we don't know whether or not it's the same every time. So I'm going to go ahead and choose my next two rows, rows 2 and 3. And we're going to have the rate of change equals, well, 780 520 over 3 minus equals, well, 780 minus 520 is going to give us 260 over 3 minus 2 is 1. Would you look at that? So far we have two rows, two sets of rows, and both of them are correct. Okay, or are the same. Now let's take our last two, 3 and 4. So now you have rows 3 and 4, and the rate of change equals, well, 1,040 minus 780 over 4 minus 3. Again, our answer is going to be 260 over 1. And now I can be pretty certain that all these three means that the rate of change is constant. So it asks up here, is the rate constant? Yes, it is. I've checked all the different and it works. They are all constant. Now, the second part of this answer was, what does this represent? Well, the fact that they're all constant means it shows band marches the same distance every minute. Every minute the band marches, they will march the exact same number of steps. And our OPA band is fantastic. Okay, so that was our first example, using a table. I don't like that because it's a lot of numbers, and I'm not very good with that. So for me, this next part I like quite a bit, which is to find using a graph. Now this one I like quite a bit. So remember that to find slope, you need rise and run. You need both, the rise and the run. So I'm going to go ahead and make go. We'll do that, and we'll do that. That works. Okay, and we're going to have 1, 2, 3, 4, 5. Good. and -1, -2, -3, -4, -5. Good. We have 1, 2, 3, 4, 5, and -1, -2, -3, -4, -5. Okay, so we're all set on our graph. I'm going to go ahead and draw. Oh, you guys couldn't even see that. I'm sorry. Why didn't someone say something? Okay, I'm going to go ahead and draw two. I'm going to go ahead and put two different points in and then draw the line. First one's going to be -2, -1. And the other point is going to be 1, 1. So we need to make sure that these connect and that it continues in the same way, moving out. That, and it continues in the same way this way as well, on and on and on. Okay, so that's my first one. My second line is going to hit at 4, or let's see, yes, 1, 4, and 5, 2. Hit those two there, and I will connect these two as best I can. There we go. Okay, so let's go ahead and calculate the slope for the red line first. The slope is going to equal the rise over the run, which equals, it's right below, which means the slope equals, in this case, what does it equal? Well, let's find our 2 points again. This one was -2, -1. And the other point was 1, 1. So let's find that rise first. Start at the lower one. 1, 2, okay. The rise is 2 over the run. 1, 2, 3. And since it's going in a positive direction, it's a positive number. And it's going to be 3. So our slope for the red line is 2/3. 2 over 3. It rises at a rate of 2 over 3. Let's go to our blue line. Our blue line has 1, 4, and 5, 2. Over the run. Well, in this case, this is going down. So we need to find the rise, and the rise can either be up or down. In this case, it's going to be down. Say is -2. So the slope (3, 4) in a positive direction, -2 over 4, which is going to give us -1/2. So that second line, the slope, it moves at a rate of -1/2. And there you go. So I like that one much better because I like looking at the actual image there. Let's move on to our next 2 examples. Okay, our next example, we've done one where we found the rate of change from a table. We found the slope using a graph. So now let's find slope using points. Let's find the slope using points. Comes in hand. So I'm going to go ahead and write. What is the slope of the line through -110 and 3, -2? Now, one way you can do this is you can write out a graph and you can fill in these. You can do it that way, but let's not do that much. let's simply use the slope formula. You have to look back in your notes to find what that slope formula was. You see it right here. So we're going to go ahead and write that slope formula down, and then we're going to solve. So let's start by saying it would be slope equals y2 minus y1 over x2 minus x1. Now, it does not matter which one you put where, as long as the 2 points coincide. So if you choose this to be your y2, then this needs to be your x2. So you need to make sure that is true. Let's go ahead and this is going to be my x and y2 because it's the second one. But it doesn't matter as long as you keep them organized. So let's start with y2. This would be my y2. So it's going to be negative 2 minus my y1, which is now here. Negative 2 minus 10. Okay? Over, now I'm going to have x2, which is right here, 3 minus x1, which is negative 1. Now, we just go ahead and solve. Negative 2 minus 10, so negative 2 minus 10 more is going to be negative 12 over 3 minus negative 1, which is actually going to be plus 1, is 4. Negative 12 over 4. Now we can simplify that. This can go in, 4 can go into 4 one time. 4 can go into 2 or into 12. Actually going to be, our slope is going to be negative 3. Not bad. So you just plug in the right points, get your answer. Okay, and let's move on to our last thing, which is kind of fun. I like this one as well, which is finding slopes of horizontal, vertical lines. Slopes of horizontal and vertical lines. So let's start with A. And let's start with a horizontal line. So I'm going to go ahead and draw, again, just a little chart or a little graph. Let's do this. There we go. Okay, so this is going to be our y-axis. This is going to be our x-axis. This one's going to be, let's say, 2. This is going to be 3 up here. This is going to be negative 2. This is going to be 2 over here. And this is going to be negative 2 over there. Okay, so let's draw in our horizontal line. It's going to be right here. Okay, so I have my horizontal line written in. We can find 2 points on that. I'm going to find this point right here. And this point over here is 2, 2. And this point over here is negative 1, 2, 3, 4. Negative 4, 2. So I have my 2 points. So first of all, there's 2 ways that we can go ahead and solve this. The first way is to do our slope equals rise. To get from there to there, there is no. So there's no rise. So our rise is going to be 0 over our run, which is 1, 2, 3, 4, 5, 6. 0 divided by 6 is going to give us 0. So there is no slope. The slope is 0. The other way to solve this is to let's do this color. We can say the slope is y1 over x2 minus x. And we just need to fill in the right things. So I'm going to say this is my y and x2. So my y2 is going to be 2 minus y2 is 2 over x2 is 2 minus x1 is negative 4. And that's going to give me 0 over 2 minus negative 4, which is actually plus 4. 6 equals 0. So either way, that'll work. Now let's look at B, because B is where things are going to get a little weird. And B is a vertical line. Horizontal line, the slope, it makes sense that there is no slope. But for a vertical, let's do that. Let's do this. I'll mark 2 on that and also negative 2. And we'll do 1, 2, 3. Let's say this is negative 4 over here. Now I need to go ahead and give myself a vertical line. The vertical line I'll find at negative 2. Yeah, we'll go negative 2. Okay, so I have my vertical line in. Again, it's easy enough to find a couple points. My first point I'm going to find is going to be negative 2, 1. Okay, so I have my vertical line. I have my 2 points. That's all I need. Let's go ahead and find the slope. And the slope equals rise over run. Well, the rise is going to be 1, 2, 3. The run, though, there is no run. They're right there. No run. Can't go either way. So it's going to be the rise, which is 3 over 0. Can you divide by 0? No, you cannot divide by 0. Let's actually even put that in. Cannot. Little bubble. You cannot divide by 0, meaning what you write for this slope would be undefined. If you divide by 0, your slope is then undefined. So a vertical line is undefined. Now let's see if it works out the same way, doing the other way to find slope with our slope formula. y2 minus y1 over x2 minus x1. Remember, it doesn't matter, so I'll just choose this as my 2. So y2 is going to be negative 2 minus y1, which is 1, over x2, which is negative 2, minus negative 2. Negative 2 minus 1 is going to give me negative 3 over negative 2 minus negative 2, which is actually plus 0. So same as 3 over 0 is undefined. Negative 3 over ahead, and I'm going to write down what our guided and independent practice is for today. Our guided practice is PPSE number 9 through 25 odd. And our independent practice is going to be our lesson -1 quiz, which is assigned on Pearson SuccessNet. And that is our lesson for today. Good luck. Have fun.